So here's the overall setup I'm using for these high voltage DC electrolysis experiments. The electrolysis cell itself is right over here. You can use whatever electrodes you want. Currently I have an aluminum one on the right there, that's the cathode, and on the left the anode is platinum. The platinum anode is 0.5 millimeter diameter, the aluminum is 1 millimeter. The electrolyte solution that I currently have is 1.5 molar potassium carbonate. The stuff in there right now is all gunky looking because it's been used quite a bit. I'll be refreshing that with some fresh solution for these discharge experiments. And I've got an oscilloscope to keep track of the voltage as well as the current. I need to hook up a current measuring probe, which I've got the channel 1 and 2 on the oscilloscope to measure the voltage from the rectifier that's across the electrodes, and I'm basically doing a math measurement through the oscilloscope to then display the actual DC rectified wave coming out, the DC rectified signal. And then channel 3 will be the current that is flowing through the cell, the electrolysis cell. As far as the power supply for all of this, it's driven by this DC rectifier module that I modified slightly to reduce the ripple a bit, so that way I don't have quite as much voltage variation in the electrolysis cell. I upgraded the original DC module from this 450 volt 220 microfarad capacitor to two in parallel 450 volt 1000 microfarad capacitors. So essentially I have a 2000 microfarad capacitance here, and you know, it's got the rectifier module here, full bridge, 4 diodes, and this thing is driven by this variac. So if I just control the AC voltage coming from the variac, which feeds into the DC rectifier module, and that gives me full control over the DC that the electrolytic cell is getting. So here's the setup with refreshed electrolyte and a new titanium electrode, 1 millimeter diameter. Still with the platinum electrode, 0.5 millimeter diameter. The titanium electrode is the cathode, and the platinum electrode is the anode. The cathode is roughly immersed about 3 millimeters, and the anode is immersed about 15 millimeters. And I'm trying to film it through this lens so I can give this camera slightly better zooming in capabilities on the electrode. I don't know if you can, how well you can see here, but this is a lot better than I had it before, because the attached lens has a pretty big field of view even zoomed all the way in, so I can't really zoom in on the electrode as much as I want, but this is quite a bit better. So let's see how it goes. This is about 73 volts. This is 50 volts. And turning it off. Alright, let's try some slow-mo stuff.